That is perfect now. So we're up and running. All right, so we already know that our product folder is here. So we are simply just open up this folder. So we, like I said, if you have the option of opening yours from your file explorer, then you can just simply do that. So VNV and then script and then that's it. Then we cd on string ID domain and then open up main VS Code. Right. Dependencies. All right. So what did we say was dependency again? What did we say was dependency again? What did we say was dependency again? Dependency. Dependency. Anyone? Dependency. Dependency. Is anyone? What's dependency? We did dependency now, and most of us even did the task and passed. Dependency. What do we say was dependency again? What do we say was dependency again? Anyone? All right. So we said that dependency is basically functions or classes which our route handler what is depending on. So then that function or those classes, makes them what a dependency. I believe that's what we define them as, right? I believe that's what we define them as. We are not communicating. Please, please I want to be sure that we are hearing me and we are following.
We can hear you, sir.
All right. So we said that the dependency is basically functions or classes, all right, which our route handler is depending on. So that makes those functions or those classes a dependency. And then I could remember vividly well when I said that the moment you pass that function as a function call within your route handler, that function does not act as a dependency any longer, because what makes your function a dependency is that that function should even execute before your request gets to your route handler. That's the whole concept of dependency. When you switch that up, then that is no longer a dependency, and that is what majority of us did. About 2 or 3 of us actually did the actual dependency concept. The rest of us just call those functions as a function call within our route within our route handler, and that violates the whole concept of dependency. The concept of dependency was nowhere to be found. Now, why are you just meant to sit together on 75 was that you solved the problem, but no doubt the problem was solved. The task that was given was solved, right? But then the whole concept that was meant to use in solving it wasn't there. Was right? It wasn't there. So the whole purpose of dependency was that let there be a function that will execute first, and when you're satisfied with that with the result of that function, then the request can then move straight to your route handler. So I mean, that request should not even get to your route handler when your dependency has not done what approve it. But then we did the other way around. We called these functions within our route handler. So it means that that request went straight to where our route handler straight before even considering the external function. So so this is the whole concept of it. So assume we have a function called a, right? And then basically a should just return something, probably hello. And then I'll just copy one of our routes here. And then we have a route like this. And then we have a route like this. Right? Now the whole purpose of dependency is that if I'm trying to navigate to this route handler, there should be a function that should execute first before the request even gets to that route handler, and that's where dependency came in, right? That's where the whole concept of dependency come in, where we simply call this and then pass this as what pass this as a dependency because of the depends function. Now when you do something like this, now once a request is being sent to this route, what happens is that this function will execute first. And this function will also be treated as a route handler. That's the whole concept of dependency. This function here gets treated as what? As a route handler. So it means that if I intend to get a query parameter, then I can simply just specify that query parameter here in that function. Say, assuming I intend to get a query of let's say limit and size. If I pass this like this limit and size won't be seen as a function parameter. It will automatically be seen as a query parameter. So Fast API will automatically see this function as well as a route function as well, but then as also a dependency. So it will treat them as route functions, but also treat them as well as a dependency. So it means that this will do what? This will even execute that all the code within here. So assuming I have about 10 million lines of code within here, that 10 million lines of code will do what? Will execute first before your request gets to where? To your route function down here. So if there is any bug somewhere there in your function there, in your dependency there, then that error, then that bug will be triggered from dependency and not from the route itself. So that means that request won't even get to the route. It gets what? It will get handled at the dependencies level. And when we are not satisfied, then we can do what? We can now go ahead and proceed to the route function. But most of us did the opposite. So instead of doing this, right, and letting Fast API to consider function A as a dependency, we went ahead and did this. We went ahead and we carried the dependency, and then we call it inside the route function. Now, once you do this, what happens is that the request is being sent directly to your route function, to your route handler, and then what? And then the function is being invoked inside the route handler. Right, inside the route handler. And then the limit and the size here does not get treated as query or path parameters. They get treated as function parameters. So it means that we need to do what? To just specify the value for limits and size there, probably 10, 20, right? And that's what most of us did. So I said, so in some questions rather, I said use dependency to do what? To validate query parameters. It means that this is the man that should validate those query parameters. But what do we do? Most of us went to the route function itself and then pass the query parameters here, a comma b, and then we do what? We now pass the a comma b to what? To this function to do what? To numbers, which wasn't actually what we were meant to actually do. I would actually advise us, if we know ourselves, take your time to do what? To understand this. If there is question, please ask pertaining to dependency. Pertaining to dependency is an important concept, right? It's far different from function call. So the benefit is that if a dependency gets the ability of handling parameters, query parameters, and rest of them, and also does what? Have the ability to do what? To handle some violations before what your request is being passed to your route handler. But when you do this, that is function invocation. That is not a dependency. Question before we proceed to today's class. Question. Question.
So I have a question.
Please ask.
So pertaining to that multi-form, when we have up to like 4, I gave 4 arguments. How am I going to put the dependency? Would I put it to each argument inside the route function?
In the case
Because
of
I did not.
multi-form, I
Mm.
can't remember, but I can't remember. I can't really remember the question though. But I think the question was supposed to tell you to let user submit certain information from form in them. So that's from HTML forms directly, right? Yes. Then you can simply treat them as you can simply use your function like this and handle them. They will still be seen as form data, right? Because that's the beauty of dependency. So if I was hoping to get your name, then your first name, I'll simply just come here and type first underscore name. And then I would make this make it of annotate. I think it's not important, but this is just for demonstration step. And then I'll just do it as form. And then when I pass this function to this route handler as a dependency, then it will automatically treat this the way it should treat it. So it will be as if this is treating this as your route function. So in the same way you will have handled it in your route function, handle it in your dependency function, and it will be treated appropriately. So now once a request is being made, what happens is that it will fire up this dependency here, and since this dependency has some parameters that is expecting data from form, then the dependency will throw the error. The error that will now come from the dependency itself, not the route handler. That certain information is what is being required. And then once those information is now being required, we can do what we can carry out our validations here. And then at the end of it, do what finally once we finish passing once we finish handling the validation, then we can do what we can simply return the appropriate values and then use them within our route function there. Do you understand?
No, sir. To be truthful, I don't still understand.
Okay. Right. Let me see if I can lay hands on that question. Is there anyone here that is not on the current stage? The sincere now features. Anyone that's below the current stage. All right. So let's
Yes,
let's
there is.
wow. All right. Who asked the question, please?
The one that asked the question.
Who asked the question? Okay, Precious Steve. What do we do? What do we do? What do we do? Let me see if I can get that question. Let's see. Okay. Let's see. Let's see. Let's see. So the question was right. So the question didn't actually specifies what information should be gotten from the form, right? So the question simply said that that we should do what? Handle multi-part form. Multi-part form data actually mean that there are some data that are coming in as files, and also they're coming in as what? As text as well. So in that case, if you remember when we treated form data, I said that when submitting files, the files are usually encoded in a different has a different encoding, right? So as such, so the way you would handle a file is different from the way you would handle form data, right? So in this question here, we are simply requested, right, that we should provide endpoint that should handle both text data, right, and file as well. So this could serve as your text data, an example. So you could also have another one. You can also have another one, and we will call this last name. Last name, right? And these are what? And these are all form. These are all form data. Please let it be known that if I see this sample in upcoming submission, automatic 0, right? So this could serve as your samples for form data. And then what you then have to do is I probably could just put resume here, and resume here would save as request files, So when you do that, then that's basically collection of multi-part form data. So I think we still have that. Yes, we still have that HTML here. So I said that if we have different encryption type for every information that's coming in from a form, from an HTML form. So if you type any type, we have some default ones, right? So these are the 3 different encoding types, right, for information coming from form. So in a situation where you are submitting just text information, right, just text information like your email, your password, then by default, right, without you actually specifying what encryption type, by default, that man is coming in as multi-part, as application XW form URL encoded, right? But then the moment you have something like this, where there's a file, so files are being treated differently in web applications, right? So now when dealing with files, then you need to do what? We need to provide another type of then in this case we need to specifically, right, specify that this form should carry this this encryption type of application form data multipart. Right. So the endpoint was that provide a URL that do what? That collects input like this, text, and also collects this, and also collect that. That was what the endpoint said you should do. That was what that question was meant for, right? So you have, so now if I'm navigating to that endpoint, I should be requested to do what? To submit at least a text input. It could be your name, your password, your email, and also a file. So when you have a text and a file, that makes it a multi-form data, right? A multi-form data, please. So don't let that grammar to confuse you. Multi-form data basically means that we are expecting that endpoint to do what? To accept at least a text input, right, from a form, and also a file, right, and also a file, at least one file, right, at least one file. So if you actually just provided just this and this, that was just what that question actually requested us to do, an endpoint that accepts at least one text from a form, and also a file, That was what that question was meant for, right? So now if we now go back again, that's exactly what we are doing here. So even if I take this off, so if I should take this off and then provide provide a file field here, then that actually solves the problem. And also, since we were actually requested to make use of dependencies for validation, then that means we should do what? We should provide those parameters in our function, in our dependency function. But if we not actually requested to do what? To make use of dependency, then we could just simply just pass them here directly to our route function. So we cut it and then we just bring it down here to our route function and put it there, right? But since it was the other way around, where dependency should do what? Should violate this thing, then do what? We simply pass it back to our dependency, and then simply just pass it here. Probably I could call this multi. See, and this will be my dependency. Do you understand? Multi-part simply means, or multi-form data simply means at least one text, one file. Minimum of one text and one file. Do you understand?
I understand now.
Okay. Please. So that is basically that's for dependent. Any other question? That's basically that for dependent. So I wanted to clear that misunderstanding, because I think most of us actually were thinking that that we can create a function and then just call the function inside the route. No, when you do that, that is function invocation or function call, right? To make that function a dependency, please you pass it with the what with the built-in depends function from fast API. That way, fast API will do what will handle that function has issued, right? Making that function to also act like a route function. We can do what we can take path parameters, header parameters, cookie parameters, what other parameter, and every other parameter that your route function can actually handle. So you can do what it will be treated as if it's a route function. So that's the whole purpose of dependency. That's the whole purpose of dependency. Any other question before we proceed? Any other question? Any other question? Any other question? Right. So the silence means no other question. No other question. Okay. That's fantastic. Fantastic. All right. So let me create a new folder here, and we're going to be working with that folder for now. We're working with that folder. Okay, so in essence of question, we'll just move straight into what we have for today's class, relational databases. Okay, and quick one again, please. Moving forward, we will think in our next class, we are going to see how we can understand the concept of Git. So after that class, we will likely not be submitting our code as a document, on Google Drive rather. We're submitting our code directly from our GitHub repository. So once after that class, then moving forward, then we start submitting things in our GitHub uh, repository, and then so why I brought that up is that please, when we start making use of GitHub repository, please under no circumstances should you submit a screenshot of your code for me. I've been marking screenshots from stage 1 to the current stage. I still mark a screenshot. So basically, I have to retype what is there on the image to do what to validate that code. Most times I actually just use my eye and fish the bug out. Okay. Please don't submit. After that class, please do not submit image again. Then one more important thing. Please, under no circumstances should another tax be given and you submit that tax and you provide a solution for that tax using another framework. Yes, using another framework. Yes, I've marked an endpoint that was correct, right? Yes, the endpoint solved the task, but then that endpoint was written using Flask. Please, when we're given a task, provide the solution in the appropriate framework. We are doing back-end development, making use of what of Fast API. If this was Flask, believe me, trust me, we have been doing Flask from day one, right? Or if this was supposed to be Django REST framework, then we have been doing Django REST framework from day one. Okay, but then this is Fast API. So let's provide our solution using Fast API. Using Fast API. All right. So that is that for tax, right? For previous tax. So like I said, I think we are in stage 6 now. So we have like just 2 more tax, and we will never see tax again in our entire life. We never see tax again throughout the boot camp, right? So 2 more tax to go. So if you've come this far, then you should strive to be able to finish up those 2 tax, to finish up those 2 tax. All right. So moving forward, okay, to what we have for today, we are going to look at relational databases. Relational databases. So I want to assume that this is our first time of hearing relational database. So I'll take time to do what to explain what exactly is relational database. Okay, so first of all, let's even start with what exactly is database. What exactly is database? I don't think database should be the first time we are actually hearing this. There's someone that keeps coming in and going out of the call. What is database? What exactly is database? All right. So a database is basically an organized collection of structured information, typically stored electronically in a computer. Right. So all those ones are just grammar. So I think the main thing there is what is the organized collection of information. So they are so whatever means you use to do what to organize and to collect information in an organized way, then that can serve as well as database. But then we also have types of database, right? Because Mr. A can be getting data in this manner, and Mr. B can also getting in data in this other manner. That doesn't mean that Mr. B is not a database. It is, right? It's just that we have that they have different types, right? They have different types, and one of that type is what is relational database, which is what we are going to look at in today's class. So what exactly is relational, or how does relational database works? Okay, so the way relational database works is that it collects its data and save it in what in rows and columns. So it organizes data in what in a tabular format. In a tabular format. That's exactly what that is exactly what a relational database. Relational DB. So it collects data and store them in a tabular format. Right? In a tabular format. And we have a lot of them. We have so many of them, right? Out there. Okay, so I think one of the popular one that people tend to hear the most is MySQL. MySQL, and we also have PostgreSQL. PostgreSQL. We also have SQLite, and for those of us that have not heard, and the rest of the etc. etc. Okay, so those are the types of what of relational database. We have MySQL, we have SQL, and we have what SQLite. Now, the way relational database works is that in order to communicate with relational database, we have to make use of what of a specific language called SQL. Please, most people conflict these things. SQL is not a database. Please, SQL is not a database. MySQL is what is a database. Now, SQL, on the other hand, is an acronym for structured query language, and it's a language we use to do what to interact with every relational database. Do you understand? SQL is not a database. It's a language that we use to communicate with every relational database. So if I want to interact with MySQL, what I have to do is to write an SQL query. Same thing with PostgreSQL, same thing with SQLite. Right. So this databases what they understand this man structured query language. Right, structured query language. And then we may also be wondering, so does that mean that that we will now suspend Python and now start learning SQL? Yes, we could, but we won't. We could, but we won't. Now, the reason for that is that due to advancement and development, right, they've come to be a technique and a tool called ORM. How many of us have heard of ORM? How many of us have heard of ORM? How many of us have heard of ORM?
Optional also object relational model or mapping.
Exactly. Object relational mapping. So ORM, let me just put this full detail out. So this is structured. My structure is not structured. Structured now. Structured query language. And his other one is called object relational mapping. Object relational mapping. All right. So ORM. So ORM, right, is a technique that has come to manifestation to help people like you and me not to do what, not to divert from Python and go and do what and learn SQL. So ORM now comes in as a bridge that allows high level developers. When I mean of high level developers, I simply mean people that write high level programming language like you and me that writes Python. Python is an example of high level programming language. So it enables us to do what, to write our high level programming language, and then the ORM comes in as intermediate and do what, and map our high level programming language to what, to a query language in order to do what, to communicate with our database. Is that making sense? Is that making sense? Right. So the silence means that is actually doing what, making sense.
Sorry, put it again. Sorry.
All right. So I said that we're going to focus on what, on relational database. All right, being a type of database that stores information in rows and columns. Right. So a relational database, right, is a type of database that stores information or data in rows and columns in tabular format. Okay. An example of them are SQL, Postgres, and the rest of them. Then we also said that these relational databases understand a language called SQL, structured query language. So so as far as the database is concerned, you must do what you must, as far as relational database, okay, is concerned, you must write structured query language to interact with them. So when I mean to interact with them, I simply mean to either save, retrieve, delete, or update in data. So that's what I mean by what interacting with this database. So either that we are saving, we are retrieving, we are deleting, or we are updating something within that database. So as far as this interaction goes, you must do what, we must communicate with SQL. So and I say that, does that mean that we, the Python developers, we have to push away Python and now go and start learning SQL in order to do what, to interact with these databases? And I said no. That over time, some tools and technique comes into manifestation or comes into evolution, and that helps us to do what, to interact with this database without necessarily doing what, writing SQL. And these tools use the concept called ORM, object relational mapping. So the way this concept works, or the way this technique works, is that you write your high level programming code. That is, you write your Python code, and then these tools, or these tools rather, will do what, will map your high level programming language to what, to equivalent relational database, to equivalent structured query language, and do what, and interact with that database for you without you doing what, necessarily coming coming all the way down to do what, to write this SQL yourself. Does that make sense?
Yes,
Yes,
it
sir.
makes sense.
All right. So now the way SQL works, or sorry, the way ORM works is that it allows you to do what, to write your classes, right? And then it maps it. So you write your classes, right? So you write your, or yes, you create your class, rather, you create your classes in your high level programming language, and then it maps it to a table in the database, right? In the database, guys keeps coming in and going out. And it keep popping out on my screen. All right, so it allows you to do what? To create your classes in your high level programming language, be it what? Be it Python, be it which other high level programming language do we have there? Be it Python, be it C++ and the rest of them. So it enables you to do what? To write these classes in what? In that high level programming language, in the language that me and you understand, right? And then it will map those classes to what? To a table in the database, right? And then the attributes of this, let me tap this in, of these classes will be considered as columns in the table of the database. That's basically how ORM works, right? So you create your class, and what happens? It will assume that class to be what? A table, or it will consider that class to be what? To be a table in the database, and then the attribute of those classes will not be considered as what? As columns within that table in the database. That's basically how ORM works, right? And then we can do what? We can modify these classes and add some certain attribute or functionality, and then it will convert that classes to what? To the equivalent SQL code, and do and create them on the database itself for you. Do we understand? Do we understand? Do we understand? Right, so the silence means that we do what that we understand. So how do we get these ORM tools? How do we get these ORM tools? There are a lot of them out there, right? There are a lot of them out there. Right? So there is what we call Django ORM. How many of us have heard of Django ORM? Or how many of us have heard of Django? How many of us have heard of Django? Right, so about 2 people have heard of Django, right? So I also about 3 people have heard of Django. So I also assume that you've also heard of Django ORM, right? So that is one of them, right? That is one of the tools, right? Django ORM. But then Django ORM is tied to Django Web Framework. So it means that outside Django Web Framework, we cannot make use of this relational mapping. So this one is what is unique to Django Web Framework. So we can't use it. But we can use one that is independent of framework. And one of them is called, and that particular one is called SQL Alchemy. How many of us have heard of SQL Alchemy? How many of us have heard of SQL Alchemy? SQL Alchemy. This is what another ORM tools, right? And that is what we are going to do, what to use and do what, and connect or interact with our relational database. We are relational database. So Alchemy, what is framework independent. It is framework independent. So you don't have to have sorry, it doesn't actually require that you use a specific framework, right? So that this one works independently. So regardless of your framework, then you can still make use of this library. You can make use of this library. Okay, so let's see how we can do what set these things up and see how we can do what start interacting. Because before now, we've been using dictionary and list for storage, for memory storage, right? But then when we get to the project phase, we have to do what? Use actual database that will hold information. And we do what? And we can retrieve it. So for this class, we're gonna make use of this particular database called SQLite. Don't worry, this class is of 2 parts, right? So it's of 2 parts. So in this particular one here is so we do what for the purpose of understanding, and then the second part is where we do what we get to see how you can do what actually use an actual database, because the thing here is that SQLite is not good for for production. So what do I mean? SQLite is a file database, right? It's a file database, and it can be used during development like this. But then when your product is now ready and it should go live, then SQLite is not the database to to use in production, because it will not hold value. Over time, you get to see that the things that you've saved in that database get to lost, to get missing, right? And we do not want that. We do not want that. So imagine trying to go to Facebook to actually go and log in, and then it happens that your credentials is what is lost in space, and you can't do what you can't log in. You have to do what you have to go back and create another account, probably the same account again, right? But then that particular one you created before is nowhere to be found. So imagine how that will look on Facebook. So you don't want such situation in your own application. So SQLite here, we are only using it for what, for development purposes here. And in part two, we know what I'll show how you can do acquire any of this production database, right? So there are services out there, right, that provide these services, right, that provide storage as a services, and that is their job, right? You pay them for what, for this database, and do what, they create it for you, and then you can do what, you can interact. That's, you stay in your apartment and have, it's more like a Google Drive, right? But then Google Drive is not can be considered as database, because it's not saving your documents in tabular form, right? So you can't interact with it now. You can, except you have to go there and open it and manually do what, delete and update and do all those things. But then you can't programmatically interact with Google Drive, okay, because it's more like a file storage and not a database. So there are services out there that, right, that provides storage as a service, and it is our job to do what, to patronize them, because they have all the tools, right, that can do what, that can give you an efficient database. So quickly, let's see how you can set this up with what, with this local one, and then in our next class, we do what, we see how we can put these things into an actual database and not a file database. So there are three major things that we need to put in place, right? So the first thing is that, okay, sorry, four major things. The first thing that we need to do, what, we need to install SQL account. So like I said, SQL Alchemy, what, is an independent library. So it has no affiliation with Fast API. In fact, Fast API does not even recommend you to do what, to use SQL Alchemy, right? So because Fast API makes use of Python. So you make use of whatever tools you see fit that work with whatever database that you have in mind. Please note that SQL Alchemy works with only relational databases, please. This man here works with only relational databases. So if I thought you want to make use of a different type of database, let's say object-oriented or graph database, then you have to do what, you have to go ahead and look for what, a tool that will also help you do what, to write your high-level programming language, and that to do what, you communicate with your graph databases, right? So please, SQL Alchemy works with only relational database, and is Python. This particular one here is for Python programming language, right? So I also believe that it may also be available for other high-level programming language, right? It may also be available for that. So we have to, first of all, we have to actually install this man. That's because this man has no affiliation with Fast API. It's a standalone library. It's a standalone library. And then after that installation, we need to we need to do what, we need to get our database URL. So database URL is more like it's more like a URL or an endpoint that contains all the information about your database. So and then this URL varies depending on your database type and your credentials. So so Miss Macy's database URL will be different from Mr. Gaia's own, and Mr. Gaia's own will be different from Miss Precious Steve. Same thing happens when you compare to Obada own, right? So now these links are going to be different, but then they will have almost this they will have similarities, because your URL, your database URL will determine the type of database you are using. So if you're using PostgreSQL, okay, then your URL will actually contain the engine that manages what PostgreSQL alongside with your username, your password, your root, your and rest of those things. All those things now will now be tied together and then form what a URL. Then same thing happens if you're using if you're using what MySQL. So MySQL will also do what have a URL that contains what the engine that manages what MySQL. Right. So all these things are relational databases, but then different engine. Now this engine are probably to enhance performance and the rest of those things, right? But then they all work under the same concept of what of relational database. Right. So for on here, for our case here, we're gonna do what have what a database URL for what for SQLite for SQLite, and I'll show you how you can do what get that URL. And after that, then we need to do what we need to actually go ahead and do what and connect with that URL, right? With that URL. So all these things will be handled by what by SQL Alchemy. So after that, after connecting, okay, the way this particular one here is unique to SQL Alchemy, right? So it may differ when using another tools, but when it comes to SQL Alchemy, it requires that after your connection, you need to do what to provide a session maker. What they call a session maker. And what exactly is a session maker? A session maker is basically a medium of interaction, right? So it simply means that for each time we intend to communicate with the database using SQL Alchemy, we need to do was create a session. So it's more like you want to go and meet a doctor. There is a book a doctor's session right now. Is that session that you that you can do what interact with your doctor. Now once you close that session, you can no longer go back there and do what and interact with that doctor again, except what you create another session. Same thing happens here. For each time we want to do what to interact with our database, either you want to save, delete, retrieve, or update. Then for each of those times, we need to create a session and then do what carry out this interaction and then finally do what close this session, right? So and then the last thing here again is what is a, we need a base class. What we call a base class, it's a built-in class. It's a built-in SQL Alchemy class, a base class for creating our tables. All right, so we need this base class for what for creating our table. So it means for each time I want to do what I want to map our classes in our high level programming language, I need to make sure that that SQL Alchemy is aware of this class by letting this class to do what to inherit from that base class, which you will see, because of course your high level language can contain as many classes as possible. That doesn't mean that SQL Alchemy will now simply come and be like, okay, all these classes are what are tables in database. SQL Alchemy needs to know which particular class should be seen as what as a table in the database. So as such, that class should be what should inherit from that base class, from this base class. Right. So those are the three things that we, or should I say the four things that we need to do what to put in place in order to kickstart. Is there any question before we start writing this wonderful code? Any question? 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 All right, so the silence means no question. Silence means no question. All right, perfect. So let's go ahead and see how we can do or start writing this fantastic code. Let's see how we can start writing this code. Okay, so quickly, what I want to do is I would want to create. So let me delete this people off completely. Don't know how this folder got in here. Let's just break them out so it doesn't confuse us. So I'll delete this one as well. All right, and we leave that as it is. leave that as it is. All right, so what I want to do is I want to create a folder and also use this opportunity to show how we can do how we can manage our files, which we are going to look at that in more like a bigger picture, right? In more like a bigger picture. But for now, we are just gonna make use of what we have here, and then sometime in the future, I will show us how we can manage a more bigger application, because the thing is that over time, your application will tend to be to be bigger, and then you have to start managing it one by one. Start separating files so that you can do for easy maintenance of the application. So what I want to do now is I will create a file and I will call this file database. Sorry, this should be lower cases. Database dot py. So basically, this file is a file that we intend to do what to use for whatever we've done, what we've mentioned here. So whatever we need to do what to establish connection with our database. That functionality or that code will live and breathe in this file. But before we start writing that code, remember we need SQL Alchemy, because it's not actually installed by default. It's a standalone application. So we go back to our terminal and make sure that your environment is still active, because I don't want to install it directly to my hard disk. I want to install it directly to our VNV file. So confirm that your terminal is that your environment is active. Then if it is, then you simply just type pip install SQL Alchemy. Right, and that will do what? And that will install SQL Alchemy for you, and then you can simply start using it in your project. So you can start using that in your project. That is taking time. Right, so it happens that I already installed mine before this class. I've already installed mine. So that's why when you are saying requirement already satisfied. But if you're not having that this message, then it should do what it should go ahead and run the installation for you just fine, right? Just fine. Right, so let me know if there's anyone that has problem doing that, which I don't think there should be anyone having problem doing that. So you simply just type it install SQL Alchemy, and that library will be available. That's the library that we will use for our SQL technique, sorry, for our ORM technique, right? Our ORM technique, where we can use it to map our classes to table in our database. All right. So having that in mind, we can simply start establishing these connections. We can simply start establishing this connection. All right. So quick one, we need our database URL, right? Our DB URL. So like I said, this URL varies depending on databases. So a typical example of a Postgres database, right? So if this was supposed to be a Postgres, then your URL would have started like this. You would have a URL that started with Postgres, which you will see because in our part 2, we are actually going to do make use of PostgreSQL. Well, the reason for that is that their reviews are good. Okay, so they provide a lot faster computation compared to MySQL. So for that, we're gonna use PostgreSQL, right? I'm not saying that MySQL is not a good database. It's a fantastic database. I've used both, and both have saved me well, but I've never had to complain. Now, one of the major reasons why I'm saying that let's go with PostgreSQL is that we're gonna get it from a platform where that platform actually offers us this database for free for a period of 3 months, and that's what we will need for practice. Then whenever you get a project that needs to run for a long time, then of course you can still make use of that platform and simply just pay for their services. But if you don't see them, wonderful, you can do simply get your database anywhere you want to get it. But the thing is that your URL will always be the same. So a typical PostgreSQL database URL will look like this. So you have a PostgreSQL to signify that database is a PostgreSQL database, followed by a colon, followed by // followed by user. That user there is more like your username, like your database username, right? So if my username is Savior, then Savior will sit there. If it's Miss Precious, Miss Precious will sit there. If it's Obada, Obada will sit there. Okay, so that's basically what that username means. So it's more like a dynamic something there, but then almost the same thing, right? The same thing, just that the values here will always change depending on the user itself, or depending on the developer itself. So after that is what is another column followed by your password. So the database password, because another thing you should also know again is that these are sensitive information. So as such, it should not be you should not do what you should not copy it and send to Miss Precious. It simply means that Miss Precious can tamper with what with your database. Neither should Miss Precious copy and own and send to Mr. Obada or Mr. Gayos. Simply means that those people can do work and tamper with her own database, because this URL carries what your user, your password, your database password, right? Your database password, and then followed by at, and then followed by the PostgreSQL server. So this server here would vary depending PostgreSQL server. So this server here will vary depending on where you're getting your database from. So the server, of course, will sit down there, right? So if the server is Alpha and Omega, then Alpha and Omega will sit down there, right? Whatever the server name is, we just sit there. And then finally followed by what the database name itself. So if you call your database KodeCamp tags, then KodeCamp tags will sit down there. If you call it floating berries, then floating berries will sit down there. Whatever you call your database will occupy the name DB there. So at the end of it all, you tend to say that this URL get longer depending on wherever you purchase yours from, right? You purchase yours from. Okay, so that's basically a more like a structure for a PostgreSQL database, and that's what we will use. That's what we will use. So I'll comment this out for now, and then we'll come back and reference it when we want to make use of PostgreSQL. So, but for this class, like I said, we'll make use of of my SQL, of SQLite being oh, you can do this flow. My SQLite rather being a file database. So we'll simply just give me a second, guys. So we'll simply just also provide a URL for SQLite. Then, so for SQLite, the URL is simply like this. So we have SQLite. So that is the engine for that particular database. So you tend to see that they're almost like the same thing. So I believe that my SQL too will also start with my SQL. So basically, if I could see your URL, I can basically just tell what database you're using. But I don't intend for you to make me see your URL, because this URL is what are sensitive. And probably you may be wondering, so me that want to show us how to create it, won't I also show us my own credentials? Yes, I will show us, but I'll delete that database after the class, right? So that database will no longer be valid. I'll simply create another one with refresh credentials. Okay, refresh credentials. So if at all you mistakenly show someone yours and then you don't have anything at the moment in that database, you can simply just delete it out and create a new database, right? And create a new database. So for SQLite, we simply say SQLite followed by our colon. Then this time around, SQLite follows with a 3/. 1, 2, 3. Now, what happens is this. So this should cover everything. So what happens? This 3/ there, right, allows tells one that this particular database is a file database. And then what follows after this 3/ is the location of that file, the location of the file, file. So you put that location of that file there. If it's in main / something, put the main / something there. Whatever you want to put there. So, but in my case, I want it to be in the current directory of this file, of where I have my SQL, of where I have database.py, I want to also have our database file in that same directory. So I could simply just use relative referencing, saying go to current directory. So I could simply say dot there means current directory for what SQL, and I'll call this particular one. I will call this KodeCamp KodeCamp dot db, and that would be our database file. So I can simply just create this file there, right? But then there's no problem. If that file is not there, then Python will automatically create the file there, right? So you don't have to manually go and create. So you don't have to manually go and create that file. Python will automatically create the file for you. You don't have to do that. So that will be our database URL. Then after that has been done, we want to establish a connection. We want MySQL Alchemy to do what? To establish connection with with the SQLite or with our database, because if we intend for SQL Alchemy to do what? To serve as intermediary that interacts with and that helps us interact with this database, then we need to do what? We need to establish that connection. So to establish that connection making use of SQL Alchemy, we simply make use of a function called create engine from SQL Alchemy. So create engine is what we will use to do what? To establish the connection. So I will simply import that by saying from SQL. So this should be from SQL Alchemy import create underscore engine. So this is the function that we use to do what? To establish the connection. So to establish connection, we simply call a function and say create engine, and then we do what? We simply pass the database URL. That is the only required parameter. So in this case, I'll simply just pass db URL, right? But then there's one thing that happens with SQLite, right? Now, SQLite usually have a problem of multi-threading. You don't have to know the technical meaning of what I just said, but then this happens when you're using what? SQLite. So basically, we want to do what? We want to specify additional parameters. So you only want to do this when you're using what? When using SQLite. So you don't want to do this with any other database, right? Do this only when you're using what? SQLite. So that additional parameter is connect argument, and then this takes a dictionary. And dictionary says that whether it should check same thread and change it to what? To false. Check underscore same thread, and this should hold the value of what? Of false. Please, you only want to add this additional information only when you're using what? SQLite. So when we now move to production and then we start making use of let's say PostgreSQL, then we do what? We can simply come back and cut this out, right? Because the engine only requires what? The database URL. But since you are making use of what? Since we are making use of SQLite, then that argument there is what is required. Right? Due to how SQLite actually behaves when it comes to multi-threading. Right? When it comes to multi-threading. So that is that about being what. So this will do what? This is let me put some comments here so this can help us. So this is our database URL. Okay, URL. So this actually carries more. So this is more like our database credential. Yes. So this URL actually carries everything concerning your database. And then this line here, we simply do what? Connect. We simply connect to the database. So at this point, we are doing what? We are giving the privilege, or we are giving the ability for what? For SQL alchemy to do what? To interact with our database, because if it's coming in, then it has to know which the database will it be interacting with. So this line here does what? Create that connection. And I can simply do what? I can simply assign this operation to a variable called engine, because we are going to use that connection, right? Because we are going to make use of that connection at some point, right? We are, we are going to make use of that connection at some point. And then the second to the last thing is the session. Remember, I said that for each time we want to interact. So this one here simply create a connection, right? But then it does not give room for us for interaction. So you have to provide the room for what? For interaction, so that once we want to interact, right, that room, that medium will do what? Will simply know, okay, I am interacting with what? With this connection that was made with this database, right? So that's where what we want to actually do now. And to create interaction, we simply make some what? Of session maker. So session maker is what we use for interacting with the database, and session maker can be imported from what? From sql.orm. Please, this thing here, what I'm doing here is not fast API specific. So you can actually look up this configuration from where? From SQL document, from SQL Alchemy documentation itself, because this is a third-party library. So this library has its own documentation. And I saw this what I'm actually writing here is not magic. It was what, but then it is what the documentation says that we must do, right? So SQL Alchemy documentation says that we must do these things to establish connection. This thing is not from Fast API. Fast API has no business here, right? It has no business here. So this is us doing SQL Alchemy, a third-party library that has its own documentation. So in your spare time, you can simply do what? You can simply look it up to know more about this particular library. So back to session creating. So we can simply bring our session maker from where? From SQL alchemy.orm. SQL alchemy.orm. We want to import session maker. So this is the this is the model the model that does what? That helps us do what? Book session, right? So it's more like the receptionist that sits at the hospital, right? That helps to do what? Create a session with the doctor. So here it becomes what? Here becomes our doctor. The session here becomes what? The receptionist that help us do what? To interact with the database itself. So to do that, we can simply just say session maker, and then this session maker class takes in a required attribute called bind. So now this bind here is like tying something to something, right? So now if I want to be booking you session, which doctor will I be booking you the session with, right? So now let's assume that we have an hospital that has like about 5 doctors, and then you want to go and book session, then you have to do what? Bind your session to a specific doctor, right? So that the receptionist knows which doctor you'll be interacting with. So same thing happens to you. If I'm interacting with a database, which database am I interacting with? So as such, it is what? The engine. So this connection here, this connection here. So that is the database that we do that we will be interacting with. So we are simply doing binding this session to that database, so that when we create this session, and then we do what? We start to interact. We simply know that what we are interacting directly with our SQLite database, which we connected to with using the create engine function, and then we assign that operation to the variable called engine. The variable called engine. Do you understand up to this point? Do we understand up to that point? Do you understand up to that point?
Yes, sir.
All right. Right. So, but then after that has been done, we need to do what to put so few more configuration, right? And because now the reason for this particular configuration is that by default, SQL Alchemy automatically send changes that you've done to the database, and we don't want that because most times you don't want to immediately apply those changes to the database immediately, right? Most times you want to do it after you must have done what after you must have carried out some certain operation. Let's assume that the value that was meant to send to a database is waiting from it is waiting for a dependency to do what to execute. But then by default, SQL Alchemy will automatically send the changes via that value straight to the database, and we don't want that. So we want to do what to control that changes by ourselves. So to stop that, we can do what we can put in two other configuration for our session. So we don't want everything to be sent directly. We want to control those things manually by ourselves because by right, that's how it should be. Right, by right, that's how it should be. So one of that thing is that we don't want to auto commit. So auto commit is more like automatically applying changes, right? So auto commit automatically. If you don't change it to false, then it will automatically be applying every changes that you've done directly to your database, and we don't want that. So as such, we have to set auto commit to the what to false, and we also want to set auto flush to false as well. Those two things. Now, those two things that are necessary what to be configured to what to false. But then if you don't want this to be done manually, then you can leave it out. But I recommend that you do this manually. You want to be applying your changes manually, right? You don't want to be doing that automatically because that may actually have some certain problems in the future, because at times there are some fields that are waiting for something to happen in order to get the value for that field before finally pushing those changes to our database. So as such, we need to configure those things to false. And I can just simply do what still assign this to a variable called I'll probably call this uh, session or database session. I'll call it DB session. So this is the man that helps us do what to interact with our database, being what the engine up there, and the engine here does what establish the connection to our database, being what the URL up here. So I believe we are doing what we are getting that process. So this one here establish not sorry create session or sorry interact with DB, right? And then one last thing again that we needed was what, remember the base, because the base is what we use for creating or for making what a particular class to be mapped as a table. So it means that class has to do what to inherit from that base. So the base is called declarative base. So you can simply just import it and pass it as arguments and use it whenever you want to do what to create a table. So I can simply do that by saying from SQL Alchemy dot extension dot ext dot declarative. These things is required not by me, not by Fast API. It's required by the library itself. Like I said, this library has documentation, and it requires that we do these things. Right? It requires that we do these things. So we have to bring in what a class called declarative base. Declarative base. People still keep leaving and coming in. I'll call this declarative rather. Import declarative underscore base. Okay, so we are missing the import keyword. So from that, and then we can simply just call this base. And base is equals to we invoke declarative base, and then we'll be using this base or this class in our subsequent classes when we intend to do what, to create our tables that should be mapped as, sorry, our classes that should be mapped as table in our database. And that is all we ever need in the database file. So this one here, this last line here, simply do what, provide us with all the tools to create table in our database. So this one here actually comes, so this declarative base actually do what, provide you with all the tools. So without you necessarily doing what, writing SQL queries, you can do what, write your class, and then your class should do what, we will now have these tools available that we can simply use to do what, to create these tables. So that is the whole purpose of this declarative base here, is to come or is to provide us with all the necessary information that we ever need to do what, to create our tables. So that is all we ever need for our database file. Any question before we proceed? Question before you proceed? Yeah, Miss Precious, your hand is up.
Good evening, sir.
Good evening, ma'am.
Sir, please ask if we are using PostgreSQL, this is the same process the way we are connecting now.
If you're using PostgreSQL, it's going to be the same process. The difference is that your URL, your database URL will just change. So you just come here and you replace your database URL. Every other code here will remain the same. Same thing happens with every other relational database. The code here will still remain the same. The only thing that changes there is your URL. Is that understood? Is that understood? Okay, so the silence means that we understand what is happening here. All right. So now that we have our database, then we can simply do what? We can simply start creating our table. Right? We can simply start creating our table. When I say creating our table, it simply means we can simply start creating our classes that can now be mapped as table in our database. We can simply start creating our classes that can then be mapped as table in our database. Okay, so we'll create a very simple table, and then we'll do what, we see how we can interact with it. So to create a table, and what I want to do is excuse me, I simply want to create a file, and this file, I want to call this file models.py. So I'll create a new file here, and I'll call this file models.py. Now models.py here is a file that I intend to hold all our table. So in this file, I want to do what, create all tables for our application. Okay, so this is the file that will do what, that will handle those tables. Right. So now for this classes, or for this table, remember I said that we're using what, ORM, where classes can be represented as a table. So if I create a class here, say class, and then I call this class I call this class user. Right? This is how we create a class in Python. We simply use what, a keyword class, followed by the class name, followed by parentheses, followed by colon, and then you can start writing whatever code that should live within that class. But then to create a class in Python, we use a keyword called class. We use it, and then we provide what, the class name. By convention, by convention, Python classes tend to start with upper cases, which in this case, we have the capital U there for user, right? So that is by convention. So if I'm to create another class, I simply do what? Copy class, and then probably I can call this class of what? Books, right? Now, once we do this like this, right? This is our high level programming language, or this is our normal Python class. And since these are classes, we can do what? We can inherit from each other. So it simply means that let's assume that the user has an attribute called age, right? Age is equals to 20. And I don't intend to create another age for the class book. I can do what? I can simply inherit that age from user. And how do I inherit? I simply do what? I simply provide the class that I want to inherit from. It means that I'm inheriting everything from that class. So it simply means that instead of doing what? Instead of repeating every code that lives within this class inside this other class, I can simply do what? Just say pass in that class name there, and from there I can do what? I can access whatever code that lives within this class. Are we following? Are we following?
Yes, I'm following.
All right. So that's basically how that's basically what classes are in Python. And the thing is that basically everything in Python belongs to a class. But that's just a simple truth. Everything that we see in Python belongs to a class. The number you type belongs to a class of integers. And because it belongs to that class has some methods. Once you hear of method, it simply means function that live within a class. So now the trick is that when there's a function within a class, Python developers don't call it a function again. They call it a method, right? So it's basically what a function that lives inside a class. And then once you have a variable that lives inside a class, like what you have here, we simply call it attribute. So we don't call it a variable again. We call it what? Attribute. A class attribute, right? A class attribute. Same thing as saying class variable or class function, right? So it basically means that those function or those classes, those function or those attribute is local to that class. That is local to that class. So it means that whatever falls within that class, that those attributes and those functions can work for them, right? So what do I mean? It simply it means that somewhere in our Python behind the scene code, we have a class called str, right? A class called str that contains a lot of functions. Functions like is alpha, right? I believe most of us did this when we are actually trying out the task of password generation. So there's a function called is alpha that lives inside the string class. So it means that once I create an instance of that class, that whatever function that lives within that class can work for that particular object. Does that make sense?
No, sir, I didn't get the part of the object you are trying to explain.
All right. So I was saying that basically, like everything that we see in Python is an object. An object is basically an instance or a member or a blueprint or not really a blueprint, an example of a particular class. Yes, let's use an example. So everything that we see in Python is an example of a particular class. Not almost everything that is seen in Python is an example of a particular class. What do I mean? If I have a variable here called x is equals to hello, x here happens to be an example of a class called string. That's why if I should say print x, right? I can sorry, not x, print type of x. So type is a built-in function that tells if a particular object shows you the class it belongs to, right? So if I say type of x, and then I execute our code here. Let me just run this code. You tend to say that we have a class called string. So it means that x belongs to an example of a class called string, SRT. Sorry, str, and then this class has what we call class functions, what we call methods. So since X now belongs to that class, it simply means that every method that lives within that particular class can be applied to X. What do I mean? That it means now that I can simply just say print X dot capitalize, right? Dot capitalize. And it will work because why? Because X is an example of the class string, and a class string has a function that lives inside it that called capitalized, right? Called capitalized. So now if I now run this now, what happened? That function actually does work on that particular member of its own class. So same thing happens again, that if I should now say, okay, let X be be 1, right? If I should now say type of X, of course, X will belong to what? To the class of what? To the class of integer, right? X belongs to what? To the class of integer. So it now means that what? That X is no longer a member of a class string, but now a member of a class integer. So if I try to now apply a method that should only be applied to a member of a class string on it, then it tells me that I am applying a method, right? That the int class, right? That this class has no such attributes called capitalized. So there's no method that lives within that class. So those are like built-in class, and we can do and we can still replicate such classes with with the keyword called class. So I can also create my own class and be like, okay, I want to create my own class called user, and then for this user I have a function or a method, a function called hello, and then this hello here, should simply just return hi, right? Should simply just return hi. So that can be what my own class method. So now what I have to simply do is do what? Is to create an instance of my own class, because this is a custom class. It's not built into Python. We just created this one now. So to create an instance of this class, I can simply just to do what? Just to call the class name similar to what? To function invocation. So I simply call the class name, right? And then if I should now execute this now, you can now say that what that X will now be what? And will now be a member of my class called user. And what I can also apply whatever method that lives within that class, since what is now a member of that class. So if I run this now, you can see what that this belongs to what? To a class called user. Now where we are having main on and dash underscore main underscore dot user, it shows that what that class is a custom class, not a built-in Python class. Right? But then at the end of it all, it shows you the class name called user. So since X now belongs to that class, it simply means that I can now do what? Apply whatever method that lives within that class. So I can simply come here and say, okay, X dot hello, and hello will work for X because X is now a member of that class. So as such, I should have the expected whatever that function or whatever that function was to do, then I should have the expected output. So if I now run this now, I should now have hello. Okay, sorry, hi. As well, because we've done what we applied what the built-in the class function for that particular variable. Are we following? Does that make sense? So at the end of it all, what I'm trying to tell you that everything that we see in Python belongs to one class or the other, and every class has their own methods or functions that can be applied to them, right? That can be applied to them. That was just the whole thing that I'm trying to explain. Do you understand? Do we understand?
Yes, sir.
All right. So that was well, so I said nothing really shall I say nothing really concerned to what we wanted actually to do here, but then that needs to come in so we can do what, so we can understand the whole concept of how classes works, because I think we not actually cover class back then in our Python days. We not cover classes, and I don't know why that skipped. I think that skipped, but then it skipped. Right, but then There's nothing really. Please tell Mr. Gabriel that if he keeps coming in and going out again, that we will likely stay out permanently.
Good question. Oh. You
Okay.
know, we didn't talk about class, and
Okay.
there are some other things that we did also talk about. I don't know whether we will be needing them,
Like what other things?
like things like inheritance, polymorphism, and the likes.
Okay, that actually lives within classes, and at the level that we are, we won't need that deep. Okay, so we won't need that deep. So that's the whole essence of what of beginner's track is to get you what the basics and then get you to do what to build simple endpoints without actually doing what diving too deep to make things what complicated. But when we see intermediates, we now do what we now dive deep and then we start talking about what the inheritance, polymorphism, encapsulation, and the rest of them. So those are all things that happens within a class, right? Those are all things that happens within a class. Well, OOP is actually a class though. Object-oriented programming is a paradigm of programming that makes use of classes. So over time, people used to write their code one straight line, but over time things actually evolved and people start writing their classes in classes where they can have their ability to encapsulate information, provide polymorphism, and the rest of all those things. So OOP is more like a concept, right? It's a concept, but it's not for beginners track. Right? It's not for beginners track. Talk about it in the internet. Any other question? But though OOP is a very interesting concept, but it's a very sweet concept. Let me give you guys a small longer truth. It's a very sweet concept. The concept is sweet. See you guys in.
Yes, sir. I have one simple question.
Okay.
You know, there was a time that we were using import,
Okay.
whereby we have to import some things. Now, there was a particular code whereby they created some classes and
Okay.
they created something like, how will I put it now? Should I call it a dictionary or should I call it a method under the class?
Okay.
Now, after creating the method, they use dot from what we imported. You
Okay.
understand? Import this then from so. Then after creating something like x is equals to let's say Pelumi, they now put dots and then
Okay.
they called out that very thing that thing we imported.
Okay.
It's still quite confusing to me how they got to that stage.
Okay. So that is the importation in Python, and we've been basically been doing that so far. And we just did that here. So this is basically what importations. So now importations are like as a concept that we use when we don't intend to fill our entire code with what our entire script with code. So we put this code in a different files and we simply bring it into our current file without necessarily writing every code that is there. So if importation was not actually available, then you see this create engine here is a function, right? It's a function that lives in the library called SQL. So if there was no importation, then what will happen is that we will have gone to SQL Alchemy website, find for the function called create engine. We copy the entire code that lives within that function. So if it's 1 million line, copy 1 million line of code and go and put it. Before you can simply do was use create engine. So, but with the help of importation, we can simply do was bring in that file. So these things are more like source code, a Python code that lives somewhere. But then we don't want to copy or we don't want to explicitly write the code name. We simply write we don't want to explicitly write out the entire code here. So we simply wrap up that code somewhere, right? And put it probably in a function. And then we can simply just bring in that function here. So the situation we are having dot something, right? Is that probably within let's say probably if I'm saying import SQL, right? And then we know that our command is out. So in a situation where we're having dot something everywhere, right? then that would be that I am simply doing what I am simply saying import SQL Alchemy. SQL this importation here is called entire module importation. Here it simply means I'm bringing everything that lives in SQL Alchemy, both useful and not and non-useful. So now, since I'm bringing everything here, that's all the source code that SQL Alchemy have, even if it's 10 trillions, right, lines of code, or hundreds of billions of trillions of lines of code, we are simply bringing it with just one line of code. And then we can now simply do what start filtering out the ones that we want. So in a situation where I wanted the create engine, I could simply just say, okay, after bringing in the entire model, then I could simply just say, then to make use of create engine, I will simply just say SQL Alchemy dot create engine. Right, so down here now, and now went ahead to do what, to now explicitly say, okay, out of all the code that we brought in here, I want just the create engine function. So those dots that you're seeing is more like referencing. You're referencing some portion of a script, of a code, right? Without necessarily writing the entire code in our file. So I believe there's a video of that particular class somewhere in the YouTube. If you just have patience to go through it, you will definitely get that video. Models in Python. Is that okay?
Yes, sir. Thank you, sir.
Yeah, so that is the whole essence of all those things. We are simply bringing a source code somewhere without writing that source code in our script. We just go and bring it somewhere with just one line of code. And we have one line of code. All right. Any other question? Any other question?
Yes, sir.
All right, please go ahead and ask a question.
Okay. So please, the init.py, what is it used for?
If what?
The init.py, the file that
the init.py. Okay, forget that you've seen that init.py there, but don't worry. When we talk about how to manage your file, we talk about why we need init.py in all our files, in all our folders, right? So for now, you can close your eyes and assume that file is not there, right? When we talk about managing bigger routes, we'll see why we need init.py there. For now, let's leave it there, right?
Okay, sir. All right. So I have another question.
Please fire down.
Okay. So please, is MongoDB better than PostgreSQL?
Is MongoDB better than PostgreSQL? I don't know. Nah, database. So I can't come in here, and start saying, okay, this one is better than that other one, right? So I can't critique people, though I can, but I don't think I should do that, especially not in this particular code. But then it's a fantastic database. It serves the purpose of saving your data. It serves the purpose of saving your data. So what I would like to do is use both. Right? Try out both of them. Right, try out both of them, and probably you can derive because what is the thing is that the database is usually developer's preference or your client preference. What do I mean? So let's say someone walked up to a car dealer. The person has his own preference of what he needs. Probably the person is looking for a vehicle that should take him from point A to point B without necessarily being consuming a lot of fuel. Then at that point, you see that a four-cylinder vehicle is the best for that person, right? But then someone else will now come in and say, okay, I need something that will take me from point A to point B with ease, with speed and power. Then at that case, a six-cylinder vehicle it becomes the best. But does that mean that six-cylinder is better than four-cylinder? No. Even if it does better than at some point, at least four-cylinder also has its own advantage. So all these databases have their own have their own downside and also have their own good side, right? So it's all dependent on what exactly are you looking for. Are you looking for easy connectivity? Are you looking for speed? Are you looking for amount of data that I can process per second and all those things? So it all boils down to how or to what you actually want, to what you actually want. So in order to know which one will suit your need, then I would advise you try out both, right? Try out both. Is that okay?
Yes, sir. Yes, sir.
Any other question? Any other question? All right. So in the absence of any other question, we're running out of time. So ladies and gentlemen, we will likely round up this class at this point. But let's see how many we have about. Okay, we have about 11 minutes. So let's see how we can create a table quickly, and then we wrap it up for today, and then we continue in our part 2 of relational database. Okay, so going back to our models, like I said, our model is what we'll be using for what to create our table that we need for what for our applications. So we don't want to create this table inside our main.py, which we can because we are growing, right? Our application is growing. So as such, we should be able to have separate files that manage separate portion of our code, so that just in case there's need for maintenance, we don't have to run from one file to or screw on one file, one long file, and scrolling like where is that establishment of connection? We start scrolling and scrolling and scrolling and scrolling. So that should not be our portion. So we should start now to know what to start seeing how we can put code in different files. So for today's class, we've created database.py that manages connection with database. So if in the future I have database problem, I know exactly where the problem is coming from. I'll go straight to my database connection file. Without doing what, going to my main.py to be scrolling and scrolling and scrolling. I'm looking for what? For database connection. So same thing happens with models.py. So once I know that there's a table that's having problem, I know exactly where to go to. All right. So how do we now use SQL Alchemy to do what? To map high level programming language classes to a database table. So we simply do what you simply create your class in your high level language. So if it's JavaScript, or sorry, if it's C++, then you simply create your class and then just work with how your tools and says that you should do what work. But for Python, SQL Alchemy says what? Create your class, your normal Python class, which is what we've done there. And then let your class do what? Inherits from that base. Remember that base that we imported? This base here inherits from this base, because this base does what? This base gives us what? All the tools do what? To create a table. Because the thing is that SQL Alchemy won't just actually assume that all the classes that lives within your project must be a table. No, that would be false, or that would not actually make sense, because of course I can have classes, right? But then that classes should not be considered as a table. So in order for SQL Alchemy to know that this particular class should be a table, then that class should do what? Should inherit from what? From this base here, right? So what do? We simply need to import that base down to where we have our model, and then we simply just use it, and then we simply just all right. So in order for SQL Alchemy to know that this particular class should be treated as a table and not just a class, then that class needs to inherit from what? From this base. Remember this base, because this base does what? Comes with every tools needed to do what? To create your table, or needed to do what? To map your class to a table. So going back to our models, so we have our classes here. So I want to assume that these classes should be considered as our table. So should be considered as table in the database. So what do? We simply just do what? Inherit from these things. So I'll bring in what? The base. So I'll say from current directory, bring database, go ahead and do what? And import base. That's what we want, right? So I'll simply just carry base and do what? And pass it as a parameter to the classes. That way now, okay, SQL Alchemy now knows, okay, these classes should be considered as what? As a table somewhere in your database, right? Somewhere as well as database in your database, right? So now we can now do what we can now start providing what the attributes of that table. Attributes, when I mean attribute, I simply means the column, because of course a table is similar to your SQL and to your spreadsheet, right? Column and table. So for instance, for this particular table, I would assume that this table should have what first name, last name, and some certain columns for a user, right? So I can say first name, have a column called first name, right? Also have a column called last name, also have a column called email, right? Now, after having those two things, now to let SQL Alchemy know that this should be columns, or to provide some certain attributes for this column, or some certain parameter for this column, right? Something like, let's say that we want that they let this column be string, or let this column only accept integer field, and so on and so forth, right? So we can do what we can provide those things. We can actually provide those things. So this one actually comes from SQL Alchemy, right? So it says that what you can bring in what the column class itself. So there's what we call it the column class. So you can say from SQL Alchemy imports we want to import what the column class column class. All right, so column. So here I can simply say that what let my first name be equal to what to be a column. So this way this way SQL Alchemy knows, okay, that first name should be what a column, and then this column takes in one required parameter. What type of value should be stored in this column? So we can also import what the type of value that should be stored in a particular column. So we have string. So to know the available types of values, you can do what you can reference the documentation, right? And you get to see all the available types of values that SQL Alchemy actually support. So for now, I'll say string. So we have string. We also have integer. So now these values, or right, these particular values are from the documentation itself, right? So I remember I said that this column takes in what a required value, and that's what the type of value that should be stored in that particular column. In this case, I'll say string. So string should be stored here. Same thing happens with the rest. But then if you intend to see all right, so with the column class, right, we can now specify that this particular attribute should be a column, and as such should do what, and the column actually expect that you provide at least one particular kind of value, one particular type for that particular column. So in this case, we've provided what string, all right, and you will see from the step hint that the base for all string and character type in SQL it corresponds to what to varchar, because in SQL we have what we call varchar that says alpha numerical values, like string kind of values, right? So now with this, SQL Alchemy will simply map that this should be considered what a table, and so this table should have what these columns called first name, last name, and email. And this column should carry string. I can as well provide another one called ID, and then this ID I want it to be what to also be a column, right? But then this column should carry integer. Integer, and one more, and then you can see that this column can take a lot of parameters. So you go see from the term hinting there are a lot of things that we can provide for a column, right? Similar to what we saw when we had the headers and the query and the rest of the and rest of the other parameters that we can provide some built-in parameters, right, to do what, to validate or to add additional functionality to that particular attribute. Same thing happens here. So I can also add what we call primary key, right? I can also add what we call primary key, right? And then I can primary key is an attribute that takes a boolean value, right? It takes a boolean value. So I can simply set this to what, to true. So it simply means that I want to use I want to use the ID column as what as the primary key, or more like a unique key for us for identifying a specific user. And we can add as many attributes as we want, but we can add as many attributes as we want. But basically, this is the basic of how you can do what, create your table. Then one important thing again that we need to actually specify is the table name. So what would you call this table? So to provide your table name, it is compulsory that you should do. You simply use a special variable called __ table name. Okay, __ table name __ equals to, then you provide what your table name. In this case, I call it what, a table called users. So this is a class, right? My Python class, but then this class is what is inheriting from where? From base, being the bigger class that comes from what, that comes from SQL Alchemy, that provides us with all the tools to do what, to create a table. So now within this class, we need to do what, we need to provide our table name, right? So you need to provide your table name. You use this special variable called __ table name __. Then you assign what to it, whatever name you intend to do what, to call your table. And then after that, you can provide attribute, and this attribute will be considered as what, as column. So this means saying what, column ID, column first name, column last name, column email. And then each of these columns should only accept string, and this one here should only accept what, integer. And then this particular column should be used as what, as primary key. Should be used as primary key, more like a unique way of doing what, of identifying a particular user. Do you understand? Do you understand?
Yes, sir.
All right. So, but then if you intend to know more about how other things that you can add to your classes, to your table class, then I recommend, please, in your spare time, visit SQL Alchemy documentation. You can see the details of these classes, right? But trust me, I'll do my best to cover the very basic. But will I cover the entire documentation? No. But I'll cover the basics, the ones that we use most often, right? Most often. So that is that for classes, and I can still repeat this for other classes, So when we meet again, we talk about what, relationships, right? A relationship in table, relationship in table relationship. We talk about that particular relationship, and then we see how we can start doing what, interacting with this database, and then we see how we can probably get an actual Postgres database, and then we should be good to go with relational database. By next week, we should wrap up teaching completely and then start building mini projects in preparation for what, for the actual project phase, right? In preparation for the actual project phase. And then if we are going to have extra class this week, I'll also do what to relay that information with us. But for now, that information is not yet verified. So the question says, is it the same method we create our rows or records? I think I'm confused with this question. If it's the same method we'll be using to create our rows, okay, our record, now your record here was to create a record, that's a single row for your table. It will simply be the instance of this table. And once we get there, we will see how you can create a record for each of these table, for each of that table, right? So that we will answer when we start doing, we're creating some records. And for now, we are simply just doing, we're creating a blank table. hoping to start getting those records, right? Right. Any other question? Any other question? Any other question? Any other question? All right. So in absence of question, let's wrap it up there for today. Let's wrap it up there for today. Let me put this on record. I think we're done.